To part 3 of Competency 12. In this video, we will work with similar figures. Number 1. The ratio of the perimeter of ABCD to that of EFGH is 7 to 10. If EH is 9 units larger than BC, what is the value of EH? Okay, EH. All right, so what do we want to do here? So EH is 9 plus X. This implies that BC is X. Okay? All right. And then they tell us that we're working with perimeter. This means that we use K as is. So our K equals 7 over 10. So we're fine using it the way it is, because with area we'd have to square it, volume we'd have to cube it, so we're fine. All right. So 7 over 10 equals, okay, 7 is corresponding to the smaller rectangle. So we put X here, and then I'm going to say X plus 9 to make it a little easier to write. So that gives us, I'm going to write it over here so we don't run out of space. That gives us 10X equals 7 times X plus the 9. Okay, so we have to follow through with our distribution. So that, that'll be 7X. That will be 7X plus the 63. Okay, now we need to subtract 7X from both sides. Okay, now that gives me 3X. This is canceled, of course, and I have 63. Now divide both sides by 63. I'm sorry, by 3. Whoa. Okay, there you go. Now, X will be 21. The thing is we are not finished. Okay, I'm going to go ahead and circle that. Okay. All right. But what we really need is EH. So what do we have? So we have that EH equals 9 plus 21. And of course, you see that that equals 30. Okay, so that'll equals 30, and that gives us option B. Okay, all right, let's go on to number 2. The area of ACEG is 64. Okay, and the area of JLNP is 110. 110. If JQ is, all right, I'm going to write that down here. If JQ, all right, this is what we're looking for. Okay, JQ is 5 units larger than AH. What is the value of AH? So, all right, so what are we really doing? With JQ, they're saying 5 units larger, okay? So 5 plus, well, let's call this X. All right, and that means we're looking for the value of X, okay? Just as we done before. Now, we do have something a little different going on. We have a ratio that they are giving us that is associated to area. That means in order to associate it to perimeter, one-dimensional line like AH. This means that we have got to put it under the square root, which gives us 8 over, now that's 110. There is no integer value. So we have to leave it under the square root for now. Okay? All right, now we can just set that up. Okay, so the 8 is associated to x, and the square root of 110 is associated to the x plus 5. Okay, so that gives us under the square root 110x equal to 8 times x plus the 5. Okay, so now we have to distribute. We can't just divide. So 110x is going to be equal to 8x plus 40. Now, this is, it seems messy, but it isn't really. Okay, so we need to subtract the 8's and subtract the 8's on both sides, okay? So, of course, this cancels. So, what are we really going to end up with here? So, what I did is, let's see, we have 40. Okay, so what we really have is 110 minus the 8x is equal to 40. All right, I'm going to come over here. Okay, we're running out of room. Not a big deal. So, what are we really looking at? So, if I just keep this all together, we just divide by that. Okay? So in the end, we will have divide by both sides by the square root of 110 minus 8. X equals 40 over square root of 110 minus the 8. And that actually gives us the answer that we need. So let's put that in the calculator. Okay? So we have 40. All right, divide by. Now we do need parentheses. Okay, second radical. Okay, 110. Now, see how my arrow is flashing? That's telling me that if you want to continue outside the radical, you have to use that right arrow. Okay, now we're out. So we subtract the 8, close the parentheses, push enter, and that gives us the value that we are looking for, which is option C. Okay, moving on. Number 3. If the perimeter of UWRI is 51, what is the value of XZ? Okay, and we know that our two shapes are similar because, even though they're scaling, because what they've done is shown us that all the angles, corresponding angles, are congruent. Okay, so if we look at this angle, it's corresponding. And then we go over. If you see the pattern, okay, that's a clue that, hey, this is good to go. You can use it. Otherwise, because there aren't other telltale signs of the shape, then I wouldn't be able to use it. And they don't give me a scale factor and they don't tell me they're similar. So the angle measures are saying, hey, these are okay. They are similar. Okay, that being said, all right, so we know that we can use a ratio, and the one that looks like we have to use to start is 3 over 11 because those sides correspond. But before that, notice that on your larger figure, that is the only measure I have. And they are asking for this particular length right here, the XZ. Okay, well, IR corresponds to that, but there's no value for IR. Well, that's why they gave us a perimeter. So what do? We just take P Actually, no, it's not P. It's I. IR. Okay? IR is equal to 51 minus 3 minus 14 minus 10. So let's put that in the calculator. 51 minus 3 minus 14 minus 10. And that equals 24. Okay, so now we have the value that we need to get this done. Okay, so let's call xe, let's just call it our x, okay? So this is what we need to do. We need to say 3 over 11 equals, okay, notice 3 and 24 are in the same shape, so we have to go back to that. That has to be in the numerator, and then x in the denominator. Okay, so we have 3x equals 11 times 24, divide by 3 on both sides. That cancels out. And that is the value we need to put in our calculator. So it's 11 times 24, okay, divided by 3, and that equals 88, which is actually the correct option. Okay, let's go to number 4. All right. Okay. The area of ZBDF is 35. So this area equals 35. 35 square inches greater than the area of AEHK. So we don't know that area. So we need to say the area equals X, okay? So plus X. So that's how we're setting this up. And now, notice we are talking about area, and they give us FD over HK, and that's our K value, actually. That's our K. So I'm going to say equals K. All right, that is in one dimensional, but area is two dimensional. So this means we'll have to square the the 4 and the 3, take the second power. And then it says, what is the product of the diagonals? So diagonals of ZBDF. So they want these guys right here. Okay. So what we need to do is this. We need to take 4 squared over 3 squared, which is 16 over 9. Set that equal to, okay, the larger, and this is a rhombus, by the way, the larger rhombus is associated with 16, so we need x plus 35. And then the 9 is associated with the x, okay? Now we go through those steps that we've done before. Cross multiply. 16x equals 9 times x plus the 35, okay? So then 16x equals 9 plus. Now, I know it would be really simple to say 9 times 35. Don't do that on a test. Put it in the calculator. You get tired and you might make a mistake, okay? And it's not worth, like I've said before, it simply isn't worth the risk. Taking this test, that's your certification. Don't take any chances. Use your calculator for everything. I know, oh, I'm good at doing math in my head. Not when you've been sitting for 4 hours. I learned that the hard way. Yeah, I'm a pro at walking around and telling the kids, oh, sure, I see what you did wrong, blah, blah, blah. But when I'm taking one of those long tests or doing something, especially at upper level mathematics, they tell me I can use my calculator. I use my calculator. I know better. Okay, so cancel out. So now we have 7x equals 315 divide by 7 on both sides. And that will give us the value of the x. So 315 divided by 745. And yes, that is correct. Okay, but we are not finished. I know that that's option A, but that's just not the case. And look at how they gave you 35 here. What we are really looking for is A equals 35 plus 45. Well, obviously, this is not the answer. Notice what else they did to us. They put the 315. Well, that's part of the original problem. They're putting every misconception possible in the answer options. So then we should put that in the calculator and come up with 160. Okay? Yes. Okay. So I have 45 in there. I'm going to add it to the 35. Oh, okay. Well, this is 100. This is 80. Okay. Well, why don't I come up with that? Okay. Wait. Hang on. Because we're not done yet. And I said that. I said, well, we should come up with 160, but we don't. We come up with 180. Why? Why is that true? Because let me show you. We do this. Okay. This is what we need. It said, what is the product of the diagonal? Okay. So what we have is D1 times D2. We are going to call that just D for product of diagonal. Okay. So how do you get the area equaling 80? We actually get that by saying our product of the two diagonals divide by 2 equals 80. And that means D equals 80 times 2, and that equals the 160. Yes, I could have just said, oh, let's circle B, but it's a clue to you that when you end up with this area of the larger rhombus, that there was something missing. And the value of D, capital D, which is the two diagonals multiplied together, that is the clue that, yes, we need to follow through. Okay, and this is the last question in this video. And again, if you haven't subscribed, please do so. It's been a lot of fun doing all these videos. The only thing is, if we don't get enough subscriptions, everything will have to be pulled down. We're going to give it some time, but I really hope that you subscribe. And if you've already subscribed, give us a like and give us a share. Share with a friend who you know needs these videos. Okay, happy testing.